I'm Éverton from Simplified Science with CEFET, and today I'm going to solve and explain a very interesting question. In thermodynamics, the laws that conduct the relationship between heat, work, and other forms of energy are studied. More specifically, the transformation of one type of energy into another, the availability of energy for carrying out work, and the direction of heat exchanges. Thermal machines are very important in the study of thermodynamics. They are devices that have the energy capacity to transform thermal energy into mechanical work, requiring a heat source and a substance to have its volume increased to move some mechanisms such as valves and pistons, in a process that involves combustion. Combustion can be defined as a chemical reaction between a fuel body and a combustion body, causing an activation energy.
An example of a thermal machine is the internal combustion engines, like those that move the current motors. They absorb the heat that is produced by burning a mixture of fuel and air, which is periodically injected into the cylinders. Thus, the part of the energy that is released during the explosion is converted into work. Through the movement of the piston, one of the moving parts of the engine, used to convert thermal energy into kinetic energy. Today, we at the Simplified Science are going to solve a question in the 2012 CEFET MG test, which addressed thermal machines, a subject addressed by thermodynamics. So let's start.
CEFET MG 2012. Thermal machine has a closed thermodynamic cycle and is composed of two isobaric and two isovolumetric transformations. The reject heat for the cold source is 150 joules. The work during the volumetric expansion is 300 joules, and in the contraction is 250 joules. Under these conditions, the heat given by the hot source and the thermal efficiency of this machine are worth, respectively. For a better understanding of this exercise, I will draw a graph of pressure by volume. First, the question speaks of two isobaric transformation, which is when the pressure remains constant, and an isovolumetric transformation, which is when the volume remains constant. So, in the end, the graph looks like this. Then, it's informed that reject heat cold was 150 joules, that is, of all the heat it receives, it does the job and spends 150 for the cold source. Let's say that work during the volumetric expansion is 300 joules and the contraction is 250 joules. It was possible to know that big expansion, because was the bigger, happened at the top. Remembering that the type of graph is worker is equal to the area, so you can already know the cycle. Then, he did a job of 300 joules and suffering 250 joules, having the end a net job of 50 joules. With this information, we are already able to answer the question.
First, let's find the heat from the hot source. Let's use the expression of energy concentration. Amount of heat from the hot source equal work plus amount of heat from the cold source. Therefore, KH equal 200 joules. Now, we will calculate the value of the efficiency. Efficiency equal work divided by KH, all the heat he received. 50 divided by 200 equal 1/4 equal 0.25. To convert it into a percentage, we will make a rule of 3. 1 divided by 0.25 equal 100 divided by x, resulting in 25%. Therefore, the heat provided by the hot source is equivalent to 200 joules, and the efficiency is 25%, concluding that the correct alternative is letter D. This was our demonstration of the first law of thermodynamics. We hope you enjoyed and observed this very important issue. A hug and see you next!